Stanford University.
Okay, well, welcome to lecture number 13 of Stanford CS 193P, fall of 2013-14. And today I'm going to go over the requirements for your final project, and then I'm going to talk a few more slides about core data and how it hooks up with UI table view, because those two are a match made in heaven. And then I'm going to do this gigantic core data with table views demo. All right, so your final project, there's kind of two phases to your final project. One is you have to submit a proposal to us, which we'll review. We're mostly just reviewing it for scope to make sure you haven't picked too big a project or too small a project. Okay, we're not, looking at in detail of every single thing you're going to do. We're just trying to make sure that you're headed in the right direction, because over the course of the final project, you can of course talk to us and ask us questions and interact with us to kind of get an idea of getting, hitting a good target at the end. So that is really due immediately. We'd like you to get us your proposal. If you know what you're going to do, please submit a proposal as soon as possible. If you don't, get on it right away and submit it as soon as possible. Really though, by next Wednesday would be the latest we'd want to hear from you. And I hate to say that, because I know a lot of you wait until the day before a deadline to do anything, and I understand that impulse, but this is something where you want to get that proposal in sooner in case we have issues, and we can get back to you and you can iterate, maybe come up with a whole new proposal if what you're thinking about is just not going to work. Then the second phase is the final project itself, and that project, the code for that project, along with a set of keynote slides for a 2-minute presentation about your project, are due on Friday, December 6th. Okay, so that seems like that's far away. I know that's over a month away, right? It's November 6th right now, but you got Thanksgiving in there, so it's really not that far away. And so, so your final project, like a final project in any class where you get multiple weeks to do it, you do not want to wait till the last week to get started. So get started immediately. You have everything you need now to start building an application. Yeah, no late days on the final project at all. Simply, we will not accept it late. Whatever you have on December 6th at midnight, submit it. I don't care what it is, submit it, because that's all. I'm not going to accept anything late. I just can't, because we've got a lot of students who are taking this class for a grade especially, and that's a lot of my time. I have to be fair to those people, and also I have to get started grading immediately. The presentation that you're going to do, 2 minutes, it's really just going to be pitching your project to us, to your fellow classmates. You can imagine it's like you're trying to pitch a VC to invest in your company, or to do the app, or you're just trying to get people to buy it, or whatever. It's that kind of presentation. I'll leave it up to you. You can certainly do a live demo if you want. You'll need iPhone 4S or later, or you'll need an iPad 2 or later in order to hook up to this wonderful projection system we have using Apple TV mirroring. But you don't have to do a live demo. Live demos are perilous, as you can see, what I do each lecture, but they're also kind of can be effective and really a good way to show off your app. So it's kind of up to you. And that presentation is required. I will have an alternate presentation time, which is the last lecture of the quarter, which is the week before the final exam period. So that's that. Yeah, the scope is basically 3 weeks of homework worth of work. You should know by now approximately what that is. Remember, the passing credit people have to pass both the homework section and the final project separately. You can't bomb one and get an A on the other and pass this class. Your final project has to work on hardware. You have to show it working either in a demo in your 2 minutes, or if you don't show a demo, live demo in your 2 minutes, you have to show your TA. Only iOS SD code counts. So if your app has a back end, some server somewhere, you get no credit for any of that really. You're only getting credit for iOS code. Okay, so simulate your back end if you have to, or if you have the back end from somewhere else, okay, that's fine, but don't waste time doing non-iOS code in this 3 weeks, because you're not going to get any credit for that work. And you'll be graded on your proper use of the SDK and also proper object-oriented programming, and your aesthetics will matter. So don't put a big junky looking UI that's just like really looks terrible. So and yeah, don't get sidetracked on non-iOS code. That's kind of a repeat of the last slide there. So the presentation quality matters a tiny bit. It does matter. Giving a presentation, effective presentation, is a very important skill to have. all of you at Stanford should be good at that by the time you get out of here. So here's just another chance to really practice doing a good presentation. Time it, see how long it's going to take, run through it a couple times practicing. Your proposal needs to have two sections in it. Okay, the first section is a kind of an overall description. What am I doing? So this is best shown by example. So I have this example here, which is the Shakespeare Director app. So let's say you're a director at a theater company and you're going to be directing some Shakespeare plays, and this is an app to help you do that. And so it has a way to bring up a Shakespeare play from the Folio database. And then you can lay out the blocking, which is like where the scene's set up, where the people are standing and all that stuff of each scene lined up with the dialogue. And then there's also got a dialogue learning mode for people who want to learn the dialogue, learn their lines. It'll say the other parts and then it'll play, you can say your own part. So you can see that this is kind of a description of what it does as opposed to how you're going to do it. Section 2 is what parts of iOS are you going to use to implement it. Okay, it's going to have a table view with custom cells, it's going to use the camera, it's going to have text fields within popovers, it's going to use AV Foundation, it's going to have NS Timer, it's going to have core data, and here's what are going to be my entities. It's going to print out the blocking things to printer, which is something we don't cover in class. And you're required to have one feature at least that it was not covered in lecture. Okay, and so that task is on there not only so you have to learn something from the documentation instead of my kind of getting you started with it, but also so that you peruse all of iOS and find out what's in there. So don't come to me and say, oh, can you tell me a feature to do for non-iOS not covered in lecture? It's like that's part of the task for you to go figure out what's out there and pick something, okay? So that's what your proposal needs to have, these two sections. What it is you're asking to do, and then what iOS APIs you're going to use that you know of right now to implement it. Okay? And here's some notes. Again, you're going to review these slides offline to really get a good feel for what makes a good proposal, and you can ask on Piazza for clarifications, etc. Okay, so the next topic I want to talk about is core data still, but it's core data and table view. How core data and table view go together. Because core data is a bunch of objects, a big object graph, and table views are really great for traversing through object graphs. Okay. So how do we do this? There's a great class in iOS called NSFetched Results Controller. This class's only purpose in life is to link an NSFetch request, which hopefully you remember from 2 days ago lecture, with a UI table view. That's what it does. It just basically bonds those two things together so that the fetch, anything the fetch would be fetching, is always showing in the table view, even if the database is changing underneath that fetch request. Okay, it's still going to be updating in the table view. So the way this works is really two parts for the fetch results controller. One is it answers all the questions in the UI table view data source protocol, like how many sections, how many rows in sections, and even some ones that you don't know about, some more advanced ones. It answers those questions as well. So it's able to answer all those questions using code kind of like that. Also, it can tell you at any given time what thing in your database, what entity in your database is being shown in a given row. Okay? There's a one-to-one mapping between a row in the table and some object in the database. All right? Because of course we know that when you do a fetch request, it can only return objects of a certain kind, an array of objects, and so this will let you get it. And it's a very important method to understand, which is object at index path. Okay, you send that to the fetch results controller, and it will return you a photo star or a photographer star or some NS managed object star, which is the object that's at that row. And then you can pull out the attributes and put them into your UI table view cell in cell for row at index path. Okay, it's really important to understand that method. How do you create one of these NS fetch results controller? Okay, it's alloc init looks like this. It takes a fetch request, a context. That's obviously where we're going to be doing the fetching, right? It'll even do section headers. So you specify which attribute in the objects that you're fetching is the section, the name of the section, and then it'll divide the table into sections. And it can also do caching. Okay, so we'll talk about those last two things in a minute here. But let's take a look at what kind of fetch request we might create to put into a fetch request controller. So here I'm creating a photo request, so I'm going to be fetching photos. I need a sort descriptor that says what order these photos are going to be in the table view, so I'll sort them by their title, let's say. And then a predicate. I'm going to get all the predicates that were taken, all the photos rather, that were taken by a photographer with a given name, photog name. Okay, so I just specify the predicate. So I just basically create a normal NS fetch request, and then I just do this fetch results controller, alloc, fetch request, context, section key name, and cache. It's as simple as that. Okay. Now, oh yeah, so those last two items. The cache, by the way, one thing about the cache, you can, if you specify nil, it won't cache. Caching means that it'll cache the results of that fetch between launching of your app. In other words, it'll permanently, you know, on disk cache it. This is not caching it in memory. You know, it's always going to do it in memory caching. Core data does that. So this is making it so between launches it has that result cached. But if you set that to non-nil, okay, you better keep your fetch request exactly the same. If you change anything about your fetch request and come back and try to use that cache, it's going to fail. So this is only really for table views that have the same fetch request all the time, exact same predicate, sort descriptors, everything's the same. If you're going to use that section key thing, try and put sections in your table view, the sort descriptors have to match up with the section keys. In other words, the rows in the table, the photos that you fetch, have to be in the exact same order that the section headers would be. And this is a normal table view thing, right? The section headers always have to be in the same order as the rows. Well, that's true here too. So almost always, your first sort descriptor will be the section key header to make sure that the thing is sorting in the same order. The fetch results controller also has a delegate, and using that delegate, it can watch what's happening in core data, and when something changes that would affect your fetch request, it'll change your table, which is incredibly cool. Okay, that means if you added a photo and it would have matched your fetch request, it'll add a row to the table. And you don't have to do anything because it's watching. It's using that NS managed object context objects did change radio station. It's listening to that and it's changing it with methods like this. Okay, so there's really two things to get a fetch request controller hooked up to your table. One is you got to use it to implement all those UI table view data source things, and two is you got to set its delegate and then use all these methods to have it watch. But we've made that easy for you. I've created a class called Core Data Table View Controller, and I'm going to make it available to you. All it does is those two things, and you're welcome to go look at the implementation of it. It's all pretty much just one-liners that are just using the fetch results controller to implement the data source and to do the delegate business. Okay, the only thing you need to know to use Core Data Table View Controller, it has a property called Fetch Results Controller, and you just set that to a Fetch Results Controller and it'll just work. Nothing else required to do. You just set that, and Core Data Table View Controller will then use it to answer all those data source questions, and also it'll set the delegate of the Fetch Results Controller and make it so it watches the database properly. Okay? So that will be included in your homework. You will definitely want that for your homework. I will be using it in the demo today. All right, so speaking of the demo, this is a huge demo. I may not get all the way through it. It covers some things that I haven't covered in lecture yet, and that's kind of intentionally. This is the only lecture I really do that, but I just want to kind of show you some things that I didn't really want to spend lecture time on. I might come back to these in future lecture, but anyway, there's a lot there to cover, and you have these slides in front of you. Hopefully you can see what the list there is. I'm not going to come back to the slides, so coming up, today's your last homework. We have an instruments, which is a performance monitoring adjunct to Xcode on Friday's section. And then next week we're going to talk a little bit about multitasking. I say more multitasking because I'm going to do some of that in the demo today. And then we're going to do some more advanced segueing. So far the only segueing we've done is